Hello, my name is Evelyn Ramirez. I'm in General Physics 1. My group is Group 5. My teammates are Angel Macario, Abigail Macier, Clarissa Cerros, and this is our lab report number 7. So the objective for today's lab, we will use an output machine to invert the direction of the force used to lift an object. We will use two masses and calculate the experimental and theoretical acceleration while adding more pulleys and loops as we progress more into the experiment. For the procedure, we first begin the lab by selecting which two masses we will use for the experiment. Then we will label these two masses M1 and M2, in which M1 will be greater than M2. Then calculate the theoretical acceleration. To set the machine, we first pass the string to the pulley, while adding the M1 mass into a higher position. We then recorded the experiment on capstone as we let go of the string with the M1 and M2 masses. After we gathered the recording, we used the data given to calculate the experimental acceleration and percent error. For the second part of the experiment, we added two pulleys and selected two new masses, which had to be greater than 50 grams but less than 200 grams. We also added an extra pulley weight to our M1 mass. After we set up the machine by adding the two pulleys and masses, we recorded the experiment in capstone and collected the data to calculate the experimental acceleration. For the last part of the experiment, we had to find masses that will give us an acceleration closer to zero. For the equations used in this experiment, for the first part, we use the equation A equals M1 minus M2 over M1 plus M2 times gravity, in which gravity equals to 9.8 meters per second squared. For the second part of the experiment, we use the equation A2 equals minus parentheses 2 M2 minus M1 parentheses over 1.5 M1 plus 2 M2 times gravity. And in order to minimize the error, the inequality must be more than 50 grams. So in this case, we would use the equation M1 minus 2 M2 greater than or equal to 50.
For this lab, the materials we used were the program capstone, the passport motion sensor, 1 meter stick, and various weights for each step of the lab, as well as a pulley system for the second half of the lab. These are the Lab 7 results. First, we have Table 1, which is our theoretical acceleration. For Mass 1, we have 50 grams, and for Mass 2, we have 25 grams. In order to calculate our acceleration, we have Mass 1 minus Mass 2 over Mass 1 plus Mass 2 times gravity, which is 9.81. And we calculated our acceleration to be 3.27 meters per second squared. For our second table, we have our experimental acceleration, which we calculated to be 3.18 meters per second squared, which we had to find the percent error from there. So we have theoretical value minus experimental value over theoretical value times 100, which we calculated to be 2.75%. And this is the graph we got. Next, we have our second run, which we have 110 grams for Mass 1 and 40 grams for Mass 2. We then calculated our acceleration, which came out to 2.18 meters per second squared. And then we have our experimental acceleration that we calculated to be 1.87 meters per second squared. And for our percent error, we got 14.22%. And this is a graph from that try. And for the questions to answer, we have, is today's percent error greater or smaller and why? Today's percent error was smaller than most of our previous percent errors, and it's probably due to our setup, which was done better. And then between today's two setups, which have a more significant percent error, and between the two setups, setup 1 had the most significant percent error at 2.75%. And what other factors besides friction could contribute to your percent error? The other factors besides friction that could contribute to the percent error are the masses chosen or the mistake in the calculation.
During this experiment, we saved several challenges that affected our progress. The biggest issue was setting up the pulleys correctly. It was hard, time-consuming, and without instructions. It took time to align and balance them so the system could work properly. Another challenge was the math involved. Many of the calculations were new to us, so we had to double-check our formulas and results. Finally, one of the group members didn't show up and the other one arrived really late, which made us harder to divide tasks and stay on schedule. Despite these difficulties, we managed to complete the lab and learn how to adapt and work as a team.
I'm recording the process, okay?
Thank you, bro. We can say whatever, bro. You can still talking because I'm gonna mute the editing process. Anyways. Okay. Bro, I didn't feed that.